In this video, I'm going to show you how to make frequency distributions and histograms. So recall that frequency distributions and histograms are only for numerical data. So down here, I've got an example where we've collected some data that represents the number of credit hours completed by students who are in an elementary statistics class. And we collected data from 53 students. So my sample size is 53. I've already listed the data from least to greatest. So anytime you have numerical data, we typically collect the data and maybe put it into a list or as a list in an Excel spreadsheet. But when you have just a list of numbers, sometimes it can be hard to see any patterns or trends in our data. So here, I want to know if there are any patterns or trends in relationship to the number of credit hours completed by students who take elementary statistics. And so again, hard to see when I have a list, but what if I took this list and organized it into a table? So sometimes when we say relative frequency distribution, you can display it as a table, but you can also display this distribution as a graph. And we call these graphs, we call them histograms, okay? So histograms are very unique graphs for numerical data. Okay, so how do we create this table or this frequency distribution table, and then how do we translate that to a graph? So I'm going to show you how to do that in several different steps here. So the first thing that you want to do is you want to take your data and you want to break it up into what's called classes. And you can think of classes as categories or bins where you start counting, and that's what a frequency is. You count to see how many of your data observations fall into that particular class or category. And so I'm going to break up my data into 5 classes. You might be wondering, why did I choose 5 and not some other number? And the reason I chose 5 is just because my sample set is relatively small. I have about 50 observations. And then also if I calculate the range for my data, so remember the range is when you subtract the highest value from the lowest value, so 120 minus 9. The spread of my data is about 111. So if I take 111, a range of 111, maybe I want to divide it into 5 groups, okay? So I chose 5, but you can always change that to whatever number you want. Okay, so once I have the number of classes determined, I'm going to next calculate what's called a class width. So when I create these classes or these categories, how wide is each category going to be? So when I break up my data, right, I want to see, how many students completed between 9 and then I got to figure out 9 and what, okay? So that's the class width is going to help me determine the limits for my classes. So to calculate your class width, all you're going to do is take the range, which is the highest value minus the lowest value, and then divide it by your number of classes. Okay, so here my range is 111 and I want 5 classes, so that's going to give me a class width of 22.5. And anytime you have a decimal here, just round it up to a nice whole number. So 23 is going to be my class width, okay? All right, now this number 23 is going to help me identify my class limits. So your limits, you're going to have a lower limit and an upper limit for each of your 5 classes. So in step 2 here, you'll see that in the table, I've got 5 rows where each row represents a class. So my first class, I'm going to start with my lowest data value, which is 9, and that's my lower class limit. And it's going to go up to some upper class limit. So to help me figure out that upper class limit, let's first figure out what the next lower class limit is for the second class. So this is where my class width comes into play. I'm going to take 9, I'm going to add 23 to it, and then the number that I get, so 9 plus 23 is 32. 32 is going to be my next lower class limit. And so if my next class limit, lower class limit is 32, then that means that my first class upper limit is going to go from 9 credit hours to 31 credit hours. And then you keep repeating that process. So now if I take 32 and add 23 to it, it's going to give me my next lower class limit. So that's going to be 55. All right, so if my third class starts at 55, that means my second class is going to end at 54. And then again, repeat the process. So 55 plus 23, that's going to give me 78. So that means that my third class is going to go from 55 to 77. And then again, keep going. 78 plus 23 gives me 101. And so that means that my fourth class is going to go from 78 to 100. And then to figure out the last upper class limit, well, we just take 101 plus 23, and so that gives me 124. And so if that's 124, then that means this is going to end at 123. Okay, so now that I have my 3 classes or my 3 categories, we can go to our data set and start counting. Okay, so when you count, that's called the frequency. So how many data observations are between 9 and 31 credit hours? So you count and you'll see that there's 15 of them. Right? How many observations show that students completed between 32 and 54 credit hours? Again, count, that's 15. All right, keep going. How many between 55 and 77? Well, that's 13. Okay, and then 4 observations were between 78 and 100 credit hours. And then 6 of those observations are between 101 and 123 credit hours. And then also double check, okay? Once you have the count or the frequency for each of your classes, if I were to add up all these numbers, so this is the Greek letter, Greek symbol for sum. If I were to sum this up, it needs to sum back up to 53, which is my sample size, okay? All right, so now that I have this frequency distribution table, I can more clearly see what's going on with my data. So here I can see that, it looks like most of the students who take elementary statistics, they're probably freshmen or sophomore students, because as I can see, most of my high frequency, right, belong to credit hours that are kind of lower credit hours that match with a student who is maybe at the end of their freshman year or somewhere around their sophomore year. And then of course we can see here that we've got a few upperclassmen taking elementary statistics. So a table sometimes allows us to see patterns and trends more easily than if we had just a list. Okay, all right, so now, how do I translate this table into a graph, which we call a histogram? So to make a histogram, right, a histogram, we're going to graph our data on an axis, an x-axis and a y-axis, where the x-axis is going to represent your numerical data value, so the number of credits completed. And then the y-axis here is going to represent the frequency, okay? So if you're making a histogram by hand, you need to determine how to make your number line for the x-axis. And so the next couple of steps, I'm going to help you create that number line. So for a histogram, it's really important that the number line, right, has what we call class boundaries. So I want to take each of my classes and I want to bound them. And those are the numbers that we're going to mark on our number line here. And I want to bound them so that if a student completes, for example, 9 credit hours, I don't want that to fall on one of my markings, all right? I want to be able to create bounds that bound in those credit hours, okay? So I'll show you how to do that in the next video.